Hi, Matt. Nice to meet you. I'd love to ask you about your talk today, and you were speaking about value semantics. For those that don't know, what are value semantics?
So value semantics is, for those oldies of you out there, is what structs are in languages like C and C++. For the newer folks, value semantics is something that in Kotlin you currently experience as primitive types, so your ints, your longs, your floats. And fundamentally, value semantics is when your data is decided and represented by the values that the data holds and not by the boxes in which this data lives. So with ints and longs and floats in Kotlin, it really doesn't matter what's the box. It matters that this is a 4 and this is a 42 and this is a 5.2. And it doesn't really matter that there are multiple different boxes that live somewhere. Yeah, so basically value semantics is when your data is the most important thing and the box and the identity of the box doesn't really matter.
You're taking me back there. I haven't really talked about it since I was very active in the C++ community. And it's not something I see, shall we say, more modern software engineers talking about, with more of a focus on JavaScript and higher level languages. So for those that don't know, what are the benefits of a value-centric design?
So the main benefit of a value-centric design is because one of the core things and the more modern representation of value semantics is how it's usually surfaced right now in a lot of the languages is from a mutability perspective. So if you're using value semantics, then again, the box don't matter. It means that you cannot change something in place inside the box. You cannot mutate things by definition. And if you follow value semantics, that means that your things are immutable. And all of the benefits, not all of the, most of the benefits, you are getting them from the immutability. Mm-hmm. So immutability gives you things like you definitely are not getting any like data races or potential state corruption if you by mistake shared something across different domains in your application. Or also value semantics gives you better ways, for example, to do computation avoidance. So if you think about stuff like Compose or React, if you think about caching, caching inherently is if this value has not changed, I can skip this computation and just take the prepared result. And I just said this value didn't change. So for most of the reactive UI frameworks or for caching frameworks, value semantics is at their core. So boxes don't matter. Values matter, and that gives you like the performance benefits by computation avoidance. And there are like multiple other benefits to value semantics, but I would say that like immutability and the possibility to get high-level performance benefits from computation avoidance, those are the two main benefits of the design that goes immutable value semantics.
So it's really interesting you mentioned performance, because back in my C++ days, one of the biggest concerns with value semantics was all this copy you're going to do and the overhead of that. Yep. So as you pointed out, it has some benefits in some of the front ends and so on. What about, there are still times in the back end or with data-driven systems where you potentially have a lot of copying?
Yeah. So like two parts to this story. Part number one, you could have worse performance because of the copying in some cases, but I would argue that in a lot of the cases, the net benefit that you get from computation avoidance, because you can skip doing stuff if the value hasn't changed, it will right out win over the performance like disadvantages you get from some extra copies of the values here and there. So that's kind of like thing number one about performance. And thing number two, like with languages like C and C++, because they follow value semantics, but they mix it with reference-based semantics, and also their value semantics is not entirely, I would say, pure. What I mean by that is that structs, you should think about them as they don't have boxes, but in C++ or C for that matter, you can actually take a pointer at any point. And that means that the compiler needs to account that, well, actually, this thing can suddenly get an identity. And this is a property that stops the compiler from doing a lot of optimizations that could have done otherwise. But if you follow value semantics that doesn't allow you to leak identity outside, that is kind of like at its core identity-less, that actually unlocks compiler optimizations. And as I've shown on the slides in my talk, and I hope I convinced enough people, that actually allows you to save performance and save allocation by going identity-less and adopting value semantics. So performance benefits can potentially be there, but I would argue if you do value semantics right enough, then there should not be significant performance overhead that you notice.
And if you can get better concurrency, you can probably improve the performance in other ways as well.
Yeah, definitely.
Okay, what guidelines do you have for people that want to apply this and how they can do it well?
That's a very good question, and that's part of the story about value semantics that we haven't kind of like straightened out all of the wrinkles out yet. I would say that by default, once we get value classes in Kotlin, you should first think that if I'm getting a new data abstraction in my program, I should go value class. And you should have like understandable reasons why you are switching to data classes once value classes are a thing and fully supported by the language, the compiler, the ecosystem. So basically, your default should be value classes. When you switch from value classes to data classes, potentially could be one, if you need in-place mutability, because like some algorithms in computer science, they are at their core use mutable data structures. In those cases, value classes won't help you. And thing number two, if you just need identity because of reasons. For example, in your enterprise frameworks, in your company, you could have, again, a caching layer, but which uses the old approach and it relies on stable identity for things that it caches, and you cannot afford to rewrite it at the time to value classes and supporting that. In those cases, identity and data classes could still be something that you use, but by default, you should stick to value classes when they come out.
Excellent, thank you. So to sum up your talk today, is there one takeaway that you'd really like everyone to have had from your talk?
You should not be afraid of value semantics because you think that it's inconvenient to use, it's confusing to write and read, and it's performance inefficient. It's actually none of those things. And we will try very hard to make it so that working with value semantics is as comfortable as currently is working with all of the other capabilities that you have in Kotlin.
Excellent. Thank you very much, Marat.
Yeah, it's been a pleasure. Thank you.
Thank you.